Alright guys, so today we're talking about systems of linear inequalities. Alright, so these are going to go pretty similar to systems of linear equations, just the difference is that our solution is actually a section of a graph versus just a singular point. So, for number one, it says, show all solutions to y is greater than or equal to negative 3x minus 1 and y is less than x plus 2. It says, show the solution for the first inequality on the graph. Lightly shade your answer with one of your colors. So, I'm going to make this one my darker blue. So we're going to go negative 1, and then we're going to go down 3. 1, 2, 3 to the right 1 would put us here. Okay, and then because it's greater than or equal to, what that means is it's going to be a solid line. All right, so we have our solid line. I hate that it makes that magnifying glass sometimes. Then we're going to go up like this. Boom. And then it says y is greater than or equal to that line. So greater than or equal to means all of my y's that are above that line. So above that line would be all of these y's right here. So I'm going to shade that section in. Okay? For the next one, what it says is it wants all of the y's that are less than x plus 2. So we're going to go positive 2. Slope of 1 would go up 1 to the right 1, so it's going to look like this. I'm going to make this a, can you make this dashed? Yeah, I'm going to make this a dashed line. So as I hold, I'm going to go here, like this. Hold down like this, go here. All right. So then when we do this, it's saying y is less than that line, so then I'm going to shade all of the values below this line on the graph. So we're shading everything below the line. All right, and then our answer to this question is the intersected area. So I'm going to make this just extra dark because that section that's getting intersected is the solution to the inequality, okay? And so if you want to make sure you're highlighting all the answers, just make that section as dark as possible. That way I know the solution you're talking about. So we come down to the next one. It says find all solutions to the following systems. Well, we have the first one. It says x is greater than or equal to 0. So that's telling us an x value of 0, and it wants all of the x's that are greater than that. So we have a solid line right at x equals 0. Just like this. And then it's saying all of my x's are greater than that. So I'm shading to the right of this line. Just like this. Shade all of this section here. All right. The next one says y is greater than or equal to 0. So then we're going to go a solid line at y is equal to 0. Just like this. Whoops. Solid line here. And then all of the y's that are greater than that line would be all of the y's up here. And then the last part of this, I'm actually going to solve for y, so that's easier to graph. So I'm going to subtract 4x from both sides. 3y is less than or equal to negative 4x plus 24. Divide everything by 3. That's going to give us y is less than or equal to negative 4/3 x plus, what is that, 8? So we're going to go positive 8, 5, 6, 7, 8 would be here. Negative 4/3 would be down 4, and then to the right 3. So 1, 2, 3, 4, 1, 2, 3 puts us here. It's also a solid line because it's less than or equal to. So then our graph is looking something like this. Not like that. That was off a little bit. Going here. And then going up like this as well. Something like that. And then it wants us to shade y less than or equal to that line. So we're shading everything below. So all of this down here would be everything below. Oops. All right. And then where is our solution? Our solution is going to be where all of those three intersected. So right in here would be our solution. So shaded in dark. If you want to, you can label it, right? Draw an arrow in there and say that's where the solution is. All right, any of those things are good to make sure that I know, you know where the answer is. All right, for B. B, we're gonna have to do some solving here to make sure that we get all of the correct graphs. So if I subtract x, you would get y less than negative x plus 5. So that one's good. So we go positive 5, down 1, right 1. This is a dashed line because it's just less than. So we're gonna go dashed line, like here. Okay, it's not making it great, but you get the idea. Like this. All right. So those are our dashed lines. And it wants us to shade less than that line. So we're gonna go less than would be here. All of this section shaded in. And again, guys, the shading does not need to be beautiful or anything. Just make sure it's in the correct spot. All right, next line. Next line is saying 2x minus y is greater than 0. So let's solve for this one. We get negative y is greater than 2x plus 0, or negative 2x because we subtract 2x from both sides. Divide by negative 1, that's going to flip the sign, so it becomes y is now less than positive 2x. So it's going 0, 0. Positive 2x would be up 2 to the right 1. It is, again, a dashed line. Dashed line like this, because it's just less than. So we have our dashed line, then our dashed line going down as well. My line function is not working the greatest right now. It's awesome. So then here would be our next line, and it's saying to shade in y less than that. So y less than would be underneath that line. So underneath this line would be here. All right, so we're starting to see a section that's overlapped. We have one more graph to graph on here, and that is going to become, when we add x to both sides, 5y is greater than x minus 20. Divide everything by 5. And you get y is greater than 1/5 x minus 4. So we're going minus 4 would be here. Up 1 to the right 5. 1, 2, 3, 4, 5 would be here. Again, it's another dashed line. No equal to sign. So we're like this. And then we're down through like this. Okay. So here's that, and then it's y is greater than that value. So if we're going greater than, it means everything above that line is what we're shading in. So there's our solution, right? Where all three of our shadings are intersecting each other, right in here. So again, you can make it extra dark, add that black highlighter color, draw an arrow to it, say this is the solution. All right, any of those things are really good for making sure that I know where your solution is. All right, continuing on. It says, write a system of inequalities to describe the shaded region. All right, so for this next section, we have to basically dissect what we're looking at here. So vertical lines are always x, and it's to the left of the x. So that's telling us it's less than. Also, it is a solid line. So it's less than or equal to. Actually, I think in the key I make this a dashed line. So let's call it dashed. And then it's going to be x is less than. And then what is that value? 1, 2, 3, 4, 5. So x is less than 5 would be that first line. Our next line is going to be right here. Okay, and that is going to be y. Oh gosh, yellow is not a good color all around. We'll make it green. So this is a y, and then it's greater than, right? So then our next one is going to be y is greater than or equal to, going to treat it as a solid line, and then 1 is the value that's there. All right, and then this last line that we're going to take a look at is right here, goes through here. Looks like it's going up 1 to the right 1. Okay, so if we're doing that, that means it just has a slope of 1. So m is equal to 1, our y-intercept is equal to 0. So then the line for this, it looks like it's shaded less than. See how it's below the line? So it's shaded less than. So then we're going to have y is less than or equal to x. Okay. So taking a look at the next graph that we have, we're going to go here. So let's start with the lines first. Lines are probably a little bit easier, so let's start here. This line has a slope that is going through this point, and where's another point that it is for sure going through? Looks like it's going through this point as well. Is that a point? We're going to go to the right 2, so that's positive 2, and then we're going to go down 1, 2, 3, so negative 3. So negative 3 halves would be the slope. The y-intercept is 1, 2, 3, 4, 5, 6, 7. So it's shaded below this line. So that's y is less than. We'll also treat this as dashed. So we're just going to say it's less than negative 3 halves x plus 7, because that's how we write a line in slope-intercept form. Slope-intercept. Next line, we'll look at this line right here. So it has a b value that is equal to 1, 2, 3. Following this slope, it's going up 1 and to the right 2. So that's going to be a slope of 1 over 2. Again, this is shaded below, so we're saying y is less than or equal to positive 1/2 x plus 3. And then the last line here, this is a special one. Notice we bounce. Okay, these are our absolute value graphs. So a little bit of review from absolute value. What we need is the slope of this line, and we treat it just like vertex form. So just a reminder of what absolute value transformation form looks like. It looks like this. F of x is equal to, and then our a value is out front. X minus h is in the absolute value, and then our k value is outside. H comma k is the vertex. Okay, so in this case, the vertex is 0, 0. A is the slope of line, is the slope of the line. So then the slope of this line, it looks like we're going to the right 3, and we're going up 1. So the slope would be 1 over 3. So we have A is equal to 1/3. So then how we're going to write this equation, it's shaded above, so y is greater than or equal to for shading above. And then the slope goes first, so 1/3. It's going to be x minus 0, so x plus 0. So that's the equation, 1/3 absolute value of x. All right, we got a couple more absolute values for some good practice. So if we're taking a look at this, we have a horizontal line. That horizontal line is at y equals 0. All right, so that's going to be our first one. I want to go here, y equals 0. Our next line is going to be an absolute value graph. Let's first label the vertex. So that's up 1, 2, 3, 4, 5. So that's 0, 5, right, in h and k. The slope of this one is going to be positive or negative 1, right? We're going negative 1 to the right 1, and it's opening down. So when it opens down like this, that means the a value is negative. So a is going to be negative 1. So then we have y, and then shading is below the line, so y is less than or equal to. And then we're going to say a value is negative 1, absolute value of x plus 5, okay? Or you can write this as y is less than or equal to negative x plus 5. You don't necessarily need the 1. I'm realizing that this value, I forgot to say if it was shaded below or above. It is shaded below, so we'd say y is less than or equal to. So then our solution is right here, right? This is the system of linear inequalities. And then finally for this last one, We got two lines again. This first line is y, and it's shaded above, so greater than or equal to 1, 2, 3, 4, so the line would be 4. On the other hand, we have another absolute value graph. Okay, so the vertex of this absolute value is -2, 0. Our a value, or the slope, is up 1, 2, to the right 1. So that's a value of 2 over 1, so 2. And then this is a little bit trickier to tell, but it's actually shaded below, right? This is beneath this absolute value. So we're going to say y less than or equal to 2, absolute value of x. This would be minus h, so minus -2. Plus k is plus 0. So then if we simplify that, we get y is less than or equal to 2, x plus 2 in the absolute value. All right? And so we always need that most simplified form. So I'm going to slide that out of the way. We'll put this up here. And then there's our solution. Okay? So that's the notes. That's what systems of linear inequalities look like. As always, if you have questions, ask in class. Canvas message me. I hope you guys have an awesome day.